it's proof time again, and this time, I think we need something like this. Okay, so for this one, the angle between a tangent to a circle and a chord, or blah blah blah. So basically what the theorem says is that this angle out here is equal to this angle over here, right? That's what the theorem states, and the essence of our proof is going to be that, once again, we're going to construct, just like we did in the previous one, we're going to construct a couple of radii, and then we're going to make use of angle at centers twice angle at circumference. So, if we can find out what this, that was strange, if we can find out what this angle here is, this, let's draw it with 2 dots, that one will be 1, and hopefully those two will be the same. So let's just maybe make that a bit clearer. This whole angle here is 90 degrees, tan rad, same as the last one. So we got this angle, therefore we can find out what that angle there is, isosceles triangle, therefore we can find that angle, and that's going to be twice that angle there. Maybe this one will make a bit more sense when I actually go through it. So let's draw our construction first. So our construction, I said, was let's draw ourselves a couple of radii. And that's our only construction for this, so let's go ahead and pop it down here. Construct radii OP and OB. Excellent, we got them there. Now, we're going to let something equal x. Well, actually, I'm just going to put down this, but yeah, this whole thing here is 90 degrees. So, TPO equals 90 degrees, reason, tan, rad. Seems like quite a useful little theorem, this, because that's helped us twice in a row. So that's that. Now, I'm going to put my x over here, and sometimes people put the x there. I kind of go one or the other. Let's go for that. So, why don't we label these things? P1, P2. And this one we can also call B1. Just going to make our lives easier. Except I'm just going to put my 2 over here because I don't want to look like x squared. So I'm going to let P2 equal x. So that one's x there. So therefore P1 is 90 minus x because they both add up to 90. No need to say the reason, but we could have skipped this line and just put our reason over there. Okay, so if that's x, then B1 is also x because there's an isosceles triangle. How often do we see isosceles triangles and circles with radii? And so B1 equals x. Well, we've got an isosceles triangle there because of those radii. So therefore, this angle here, I'm going to call this O1. The obtuse angle here, not the reflex. So O1 equals, well, angles of a triangle add up to 180. So that would be 180 minus those 2 x's over there. And I should maybe have put 90 minus x over here. So that's 180 minus 2x. Why? Because of sum, that's the word sum, believe me, sum of angles in triangle behind my head. And I'm just out the way, right? And so therefore, if that's 180 minus 2x, then this one over here is 90 minus x. So A equals 90 minus x. Reason, angle at center is twice that of the angle at the circumference. Angle at circumference. Okay, so there we go. So therefore, what we've shown is that BPT, well, that was 90 minus x, that's 90 minus x, they're the same. So we've shown that those two are equal. Okay, and for your own sake, if you want to, you could have done the whole thing, and let me just do it like this, and said that, this is x, this is 90 minus x, this is 90 minus x, therefore this is 2x, therefore that's x, and just let that equal x that way around. 6 of one, half a dozen of the other. I'm going to leave it so the diagram matches what we wrote. So with that said, I think we need to go and ride with some more Valkyries. Which is quite something.